Welcome, viewers, to Bodhi Unified Flow, where we simplify complexity and amplify performance. Let's jump right in. Today, we're diving deep into the blueprint revolution, a 4-year roadmap to civil mastery. We're talking about bridging that massive gap from theoretical BTech drawings straight into the intense, muddy, and frankly magnificent reality of the construction site. This explainer is your ultimate guide to execution, covering the whole shebang, from handling labor and material logistics to mastering advanced digital quality control.
So, here's our roadmap for today's explainer. 1. Welcome to site reality. 2. Decoding the blueprint. 3. Mastering construction materials. 4. Managing the human element. 5. Troubleshooting and optimization. And finally, 6. The digital construction frontier. Let's get moving.
By the end of our time together, you're going to have the practical, real-world tools necessary to handle labor, material logistics, and quality control with absolute confidence. We're not just looking at what happens on a site, but really digging into why it happens and exactly how you can control it.
All right, Section 1. Welcome to Site Reality.
You know, the evolution of civil engineering education in India has been pretty radical lately. The AICTE now legally mandates 600 to 700 hours of credit-bearing internships for undergraduates. This totally proves that the old 75% attendance rule isn't just some annoying hurdle to pass exams. It's a fundamental exercise in building the professional discipline you'll need for site-level accountability. You literally transition from soft skills in semester 2 straight into the hardcore complexities of massive infrastructure projects managed by the PWD or MORTH by semester 6.
Once your boots actually hit the dirt, your role changes completely. Think of it like this. If the project manager is the brain, the site engineer is absolutely the backbone. You're the one meticulously managing the daily, weekly, and monthly cycles just to keep the project breathing. Every single day demands a daily progress report and safety checks. Weekly, you're coordinating materials, and monthly, you are grinding through those critical RA, or running account, bills.
Moving on to Section 2, Decoding the Blueprint.
As those classic foundational texts like NDBOT always remind us, technical drawing remains the fundamental language of engineering. Period. Your very first real trial on site is interpreting those general notes for material grades, verifying 150 scales, and translating complex structural symbols accurately. A solid thick line? That's a wall. A dashed line? Future work. If you misinterpret these symbols, or heaven forbid, the north arrow, you're looking at catastrophic dimensional errors. But how do we drag those flat, 2D drawings onto the physical, uneven Earth? We rely on some seriously advanced surveying tools. Take the total station. It gives you the millimeter-level precision you absolutely need for high-rise foundation alignments. Then you've got RTK GNSS giving you 1 to 2 centimeter accuracy for those sprawling highway layouts. And ground-penetrating radar? That literally lets you see buried utilities before your excavators accidentally rip open a water main.
Let's step into Section 3, Mastering Construction Materials.
A true master of civil engineering lives and breathes by the Bureau of Indian Standards. It's your Bible. IS 456 dictates everything about your concrete's characteristic strength and quality control. On the flip side, IS 1786 governs the high-strength TMT deformed bars that are quite literally the backbone for the seismic resilience of your entire structure. Now, if there's a magic number in concrete, it's 28. 28 days is the strict, undeniable curing time required for concrete cube testing to verify characteristic strength. And the sampling frequency? It's not just a random guess. It's tied directly to the volume you pour. Say you pour between 16 and 30 cubic meters. Well, you're going to need 3 samples. That translates to 9 individual cubes, tested precisely after 28 days to guarantee your concrete isn't porous or full of honeycombs.
But here's the thing. Material mastery isn't just about testing. It's about preservation. Cement is highly hygroscopic, meaning it greedily sucks moisture right out of the air. Under IS 4082, you have to ensure it's stored on a raised wooden platform exactly 200 millimeters above the floor, and you can never, ever stack it higher than 15 bags. If you go above 8 bags, you've got to use a header and stretcher arrangement to lock them together. Why? To prevent a deadly collapse and to make sure this highly reactive stuff doesn't lose its strength before it ever even sees the mixer.
Okay, on to Section 4, Managing the Human Element.
Construction is intrinsically human, and as the site's legal guardian, you have to ensure absolute strict compliance with the 1996 BOCW Act. That's the Building and Other Construction Workers Act. This means you're filing Form I before the project even kicks off and Form IV within 30 days of starting. But most crucially, you have to process the mandatory 1% labor welfare cess. Guys, this isn't just annoying paperwork. This money funds vital social security, medical aid, and maternity benefits for the very people breaking their backs to build your project.
And because real human lives are literally on the line out there, enforcing these Indian standard safety protocols is 100% non-negotiable. We're talking helmets matching IS 2925 and safety shoes matching IS 15298. If a worker steps above 1.8 meters, fall protection is legally required. If a trench dips below 1.2 meters, you must shore or brace it to prevent a cave-in. At the end of the day, their safety is your ultimate responsibility.
Section 5. Troubleshooting and optimization, because reality always throws a curveball.
Let's talk about the measurement book, affectionately known as the MB. This little book is the holy grail of financial transparency on your site. Listen closely. If it is not legally recorded in ink in this book, the work simply does not exist. Zero erasing is allowed. If you make a mistake, you strike it with a single line. And here's a golden rule. You must measure hidden items, things like deep foundation work or embedded plumbing, before they are covered up. The junior engineer has to verify 100% of this physical work before a single rupee is authorized for payment.
Now, the global scale of construction waste is honestly staggering. Up to 18% of materials delivered to a site can just be wasted due to poor planning or sloppy storage. Your job is to aggressively fight that. You have normal wastage benchmarks to hit: 10% for sand blowing away or mixing with the dirt, 5% for aggregates, and a very tight 3% for steel. These aren't suggestions. These are strict, non-negotiable targets you have to hit to keep the project profitable.
So how exactly do you control that 3% steel waste? You use your greatest mathematical weapon, the bar bending schedule, or BBS, unit weight formula. It's elegantly simple. D squared divided by 162, where D is the bar's diameter in millimeters. This genius little formula allows us to pre-calculate steel lengths and weights down to exact millimeter accuracy. Doing this drastically cuts down on expensive offcuts and stops you from over-ordering.
But beyond the math, you also have to dynamically troubleshoot the earth itself. Soil is wildly unpredictable. Clay soils will swell up when wet and shrink when dry, which means you have to use chemical stabilization. Sandy soils, well, they drain beautifully but have zero cohesion, often forcing you to drive deep pilings to reach firmer ground. As a site engineer, you are constantly mediating a tug-of-war between structural needs and these crazy ground variations.
Finally, Section 6. The Digital Construction Frontier.
We are rapidly, thankfully, moving away from the era of chaotic WhatsApp group updates, smudged paper logs, and manual inventory counting. Welcome to Construction Enterprise Resource Planning, or ERP. These advanced software systems give you a single source of truth. Instead of finding out your steel stock is depleted a week too late, ERP gives you automated purchase order triggers and real-time analytics. It seamlessly connects the muddy chaos of the site directly to the polished office dashboard.
Wow, okay. We have just traced the entire roadmap of a civil engineer's reality. You've now gained the foundational tools to truly interpret complex designs, mandate unyielding material quality, uphold vital labor welfare laws, ruthlessly prevent costly waste, and step up to lead the charge as a modern, digitally empowered site engineer. Here are the key references that form the bedrock of everything we've unpacked today. We really hope this Bodhi Unified Flow Explainer has equipped you with the confidence to step onto any chaotic site and transform abstract blueprints into massive, enduring infrastructure. The tools are firmly in your hands now. So, what groundbreaking project are you going to build next?